To begin Chapter 5, we want to take a look at linear inequalities. This is what they look like. So we're going to draw the graph of this linear inequality. To do that, we have basically these three things that we need to do. Number one, we need to graph the associated line. You can see down here at the bottom, I've just written y equals 2x plus 1, which is like the inequality, but with an equal sign. Now to graph that, we know that the process would be to put a dot at 1 on the y-axis and then count up to and over 1 from that dot. And so that would be the graph of the line associated with the inequality. Now, in looking at the inequality, we need to decide, is that line dashed or solid? A solid line indicates that the line is part of the solution. A dashed line means that the line is not part of the solution. Now, since the inequality symbol has a line at the bottom, that means equals. And so the line is part of the solution. So the line under the inequality tells us that it will be a solid graph. And finally, we need to decide which side of the line to shade. I've got these color-coded, red and green. We need to decide whether to shade above the line or below the line. The way to decide that is to pick a point somewhere that we know is obviously above or below the line. For example, that point has coordinates 0, 0. If we use a 0 for x and a 0 for y in the inequality, y is greater than 2x plus 1. That's 2 times 0 plus 1. Is 0 greater than 1? No, it's not. Well, since the dot we chose does not work in the inequality, then we cannot shade the side where that dot is. That tells us that we need to shade the other side. So there's the graph of that inequality. Now I'll go through these a little quicker. Here's another similar looking one. You can tell it's going to have the same line as before, only this time, since there's not a less than or equals, since there's not a line at the bottom of the inequality, the graph is going to be a dashed line. And again, we need to learn, well, whether we shade the top or whether we shade the bottom. If we pick out a point that is obviously on the top or the bottom, like again the point 0, 0. The point 0, 0 would give us 0 is less than 1, which is true. 0 is less than 1. So we need to shade on this one the bottom of the line. Here's one. Now we'll graph the line differently this time. To draw the graph of x plus y equals 4, we need to put a dot at 4 divided by 1 on the x-axis and 4 divided by 1 on the y-axis. So we'll have a dot at 4 on the x-axis and 4 on the y-axis. So the line would look like this. And again, since there's not a less than or equals, that's going to be a dashed line. And then we need to shade the top or the bottom of that line. Here again is the point 0, 0. Plugging that in, we get 0 plus 0 is less than 4. That is true. So we need to shade the bottom where that dot is. Here's another one, larger numbers, but same idea. Graph the line, 15x minus 4y equals 60. Is it solid or dashed? It would be solid. And we need to shade top or bottom. The point 0, 0 would give 15 times 0 minus 4 times 0, which is 0. 0 greater than 60 is not true, so we need to shade the bottom part of the line. Here's a strange equation, but the same idea. Graph the line, make it dashed, and shade one side or the other. You can tell from y greater than 3 that we want to shade above the line. Here's the same thing with x's. Here's the line, x equals 2. It's solid. We need to shade to the left. Systems of inequalities simply means that you got two or more of them going on at the same time. So here's what we will do. We will graph each line individually. This inequality would have this line, crosses the x-axis at 6 and y-axis at 6. We need to pick a point like 0, 0. 0 is greater than 6. That's true. That's false, sorry. And so we don't want to shade the bottom of the line. We'll shade the top of that line. Here's the other one. I'm going to graph it over here on the right side so you can see the line that's associated with it is a solid line. We can't use the point 0, 0. We can use the point 2, 0. So the point 2, 0 would give us 4 greater than 0. That's true. So we need to shade the bottom of that line. Now if we blend those two together, the part where they overlap is our solution. This is called an unbounded region because it goes forever. Here's another one. We will graph the first one as an x-intercept at 24 divided by 3, as a y-intercept at 24 divided by 4. So here would be the graph. Now the other two, x greater than or equal to 0, simply means the values to the right of the y-axis, and y greater than or equal to 0 means values up above the x-axis. So there would be the region. This is a bounded region because you can see there's lines on every side. Now, let's notice first off, like on the last problem, the x greater than 0 and y greater than 0 just means we're talking about quadrant 1. So we'll get that out of the way real quick. And then we'll graph each of those one at a time, starting with the top one in yellow. Here's the line that's associated with that, and we're shading below the line. The second one, red, here's the line. We're shading below the line and above the x-axis and to the right of the y-axis. Here's the last one in pink. Here's the line. And again, the part where it overlaps is our region. That's a bounded region. The dots where each of the boundary lines intersect are referred to as corner points. We can find those corner points simply by recognizing the associated lines. The first one is the x-axis and the y-axis, and that would be 0, 0. Here's the x-axis and the yellow graph. So what's the x-intercept of the yellow graph? That would be 11. So that's the point 11, 0. Here's another corner point. We can probably tell by looking, but remember that's the pink graph, and it crosses the y-axis at 50 divided by 5. And we can find this corner point, like we did in the previous chapter, by using our Gauss-Jordan method and the RREF. Now, I won't go through that here, but that corner point comes out to be 9 and 4. And we can find the last one the same way by taking these two equations and doing the RREF method. So that is how we find the corner points.